In this work, we use an off-policy reinforcement learning algorithm, specifically the soft Actor-Critic, combined with domain randomization to address autonomous pre-capture planning for a free-floating moving target. We created an environment using PyBullet, where at each time step, the target is randomly positioned relative to the gripper with random velocity. This domain randomization helps reduce the gap between simulation and real-world performance. The agent in this setup is a gripper that receives observations and determines the best action to complete the pre-capture mission. The observation is a 40-dimensional array consisting of information about the gripper and the target. The action is a 6-dimensional array, representing both directional and rotational displacements for the gripper. We designed a unique reward function to guide the gripper on how to approach the pre-capture position without touching the target. Since the target is free-floating and moving, even slight contact could destabilize the system, causing the gripper to miss the opportunity to grasp the target. Our reward function has 4 parts. The first 2 guide the gripper to reduce pose differences, with values bounded between 0 and 1. The third part encourages the gripper to position the target within its palm, and the last part penalizes any contact with the target. The results are promising. After around 24,000 episodes, the agent successfully learned how to handle the moving target, maximizing its reward at each time step. The success rate, defined as achieving more than 2 positive rewards at each time step for over 200 consecutive time steps, reaches about 91%, demonstrating the robustness of the agent in various situations. Here's a random episode from the simulation environment after training. You can observe how the agent reduces the distance without touching the target, while consistently maintaining its reward close to the maximum possible value of 3 at each time step. We then deployed the trained agent at the unique testing facility at York University in Canada. The target is again randomly placed, and the gripper, using the trained agent, attempts to position itself for pre-capture without making contact with the target. All required observations are gathered from sensors and passed to the agent to predict the optimal action. For safety reasons in the real world, we used a stationary target. The gripper moves one action at a time, based on how often new observations are available, which depends on the latency of the sensors. As new data is collected, the agent applies the corresponding predicted actions to the robot. Thank you for listening, and I look forward to seeing you in Yokohama.